Good morning, guys. This is going to be Notes 3.006. This is Parent Functions, Not Rigid Transformations, Part 2. Today we're going to be looking at horizontal dilations. The last class we talked about vertical dilations, and so now we're looking at horizontal. Horizontal dilations change the shape by either expanding or compressing it, kind of like the vertical, but more along the x-axis than on the y-axis. The vertical dilations, either squish the graph from the top and the bottom, or stretched it. Now we're gonna, squish or stretch the graph on the x-axis. These are a couple of the formulas, and so if we have a value that we're multiplying that's bigger than 1, we have a compression, and then if we have a value that's between 0 and 1, it's an expansion. And so what the horizontal dilation affects is more the x values. So if you remember with vertical dilation, we were multiplying the y values. Now the y values are going to stay the same, and we're going to be multiplying the x values. Okay. So these are the 5 examples we're going to do, and there's actually a total of 7. But after I graph example 5, then I'll jump to 6 and 7, and I'll show you what those are like. Okay, so for example 1, the type, if we state the type first, it's in absolute. Absolute value. And then, absolute value. And then the values are -1, 1, 0, 0, 1, 1. Okay. And so if I graph these, it's going to be 0, 0, 1, 1, -1, 1. Something like this. And then going the other way to make that B shape. So remember, absolute value has that V shape, right? And so what we're going to do is look at what's happening to the function, and we notice that there's a 3. We notice that it's inside. It's multiplying inside. So I'm just going to put inside, which means we have a horizontal dilation. Okay, before I continue here, I just want to shift this over a little bit just to kind of show you what we're going to do. So for this one, we're actually going to work it out a little bit different. What we're going to do is we're going to plug in the x values into the equation to get our y values. Okay, so we're going to kind of get a new table. So I'm going to plug in, plug in this value into the equation, and so the equation is absolute value of 3 times -1. That's going to be -3, but anything that goes inside the absolute value is positive. And then take this x value of 0, plug it into the equation. 3 times 0 is 0. The absolute value of 0 is 0. And then the last one is 3 times 1 equals the absolute value of 3, which equals 3. So my new points are going to be -1, 3. -1, 3 is up here. 0, well, I plugged it in and I got 0. So the other point's going to be 0, 0 again. And then the other point is 1. When I plugged in 1, it gave me 3. So when I plugged in 1, it gave me 3. It's going to give me this. Something like this. Yeah, so if you notice, it kind of compresses it a little bit differently this time. But it's a horizontal compression, so it's kind of squeezing the parent graph, the blue graph, closer to the y-axis. So it's squeezing it from the left and the right and putting it closer together. All right, let's go to example 2. This time we have a square root. The points of the square root: 0, 0, 1, 1, 4, 2, and 9, 3. Okay. So 0, 0, 1, 1, 4, 2, and 4, 5, 6, 7, 8, 9, 3. Yep, that's it. So that's my parent function. All right, for this one, if you notice, we have 1/2 inside, so we have a horizontal dilation, and we're going to do this one a little bit different. So for absolute values, we just kind of plugged in the value into the equation. For square roots and cube roots and cubics, we're going to do it a little bit different. We're going to do the opposite of the operation that's there. So if you notice here, it's multiplying or dividing by 2. Right? What's the opposite of dividing by 2? Multiplying by 2. And we're only going to multiply all the x's. So if I multiply all the x's times 2, 0 times 2 is 0, 1 times 2 is 2, 2 times 4 is 8, 2 times 9 is 18. But I don't think we'll be able to get to 18 because our graph, I don't think it reaches 18. But this is going to be my new set of points. It's going to be 0, 0, 2, 1, 8, 2, and 18.3 is somewhere down that way, right? So again, the reason that we multiplied by 2 is, remember, anything that happens inside. So let me write it up here. Since this happened inside, we do the opposite. Even for horizontal translations, right? If it says plus, we go to the left. If it says minus, we go to the right. It's the same idea here. So just do, if I have a multiplication of a value inside, then we're going to do the opposite. Right? It's multiplying times 1/2. What's the opposite of 1/2? 2. So let's keep practicing this. Let's go over to example 3. Now we have a cube root. And so the values for cube roots are the following. Eight. So 1, 2, 3, 4. Right, so we have 1/4 inside. So we have a horizontal dilation. And so we're going to multiply all the x values times the opposite of 1/4. Okay, the opposite of 1/4 is 4. So -8 times 4 is negative 32. This is -4. This is 0. This is 4. This is 32. So we probably won't be able to go to 32 because it's too far. But at least we can do the other ones. Like for example, we could do -4, -1. -4, -1. There. We're still going to have 0, 0. We're still going to have 0, 0. And then we're going to have 4, 1. So we're going to have something like this. Okay. Let's go to example 4. This is a cube root. And so the values are -8, 2, -1, -1, 0, 0, 1, 1, 8, 2. One, 2, 3, 4, 5, 6. All right, and so here we have horizontal dilation, and then we have this +5 which is a vertical translation. Up 5. Okay. So let's do the horizontal dilation first. So we're going to multiply all of these times the opposite of multiplying, the opposite of multiplying times -2 is dividing by -1/2. So we're not going to change the sign, but we're going to change whether we're multiplying or dividing, right? Because the opposite of multiplying times 2 is dividing. So if I multiply all these times -1/2, negative times a negative is positive, right? Negative times a negative is positive. 8 times 1/2 is 4. Negative times a negative is positive, so that's going to be positive 1/2. This is 0. This is going to be -1/2. And this is going to be -4. All right. And so our new points are going to be, first one is going to be 4, -2. 4, -2. So I'm going to go to the right 4 and down 2. The next point is 1/2 -1. So I'm going to go to the right half and down 1. Then 0, 0. Then I'm going to go to the left 1/2 and up 1. And then the last one, I'm going to go to the left 4 and up 2. Okay, and I'm also going to move all these points up 5 units. So it's going to be 1, 2, 3, 4, 5. So I'm actually going to pick, I'm going to pick a different color for the graph. Should I pick? I'm just going to pick orange. Okay. Move it up. Move this one up. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Wait, let me fix this a little bit more. That looks crooked. Okay, something like that. So the orange graph is my transformation, and the blue one is my parent function. Okay, let's go to the last graphing example, and then we'll do 2 more function examples. So this one is a square root. Points are 0, 0, 1, 1, 4, 2, and 9, 3. 0, 0, 1, 1, 4, 2, 9, 3. Okay. For this one, I'm going to pick a different color for the dilation, but same idea. You know, we have a negative 2 here. So this is a horizontal dilation. And then the minus 1 is outside. So that's, we're going to go down 1. So for the horizontal dilation, what's the opposite of multiplying by 2? Dividing by 2. But we're going to multiply all these by 1/2. Or in other words, divide all these by 2. By negative 2. Because the original one was negative, so kind of keeping in the same mindset, we're going to multiply all these times negative 1/2. Negative 1/2 times 0 is 0. Negative 1/2 times 1 is negative 1/2. Negative 1/2 times 4 is negative 2. And negative 1/2 times 9 is negative 4.5. So if I graph these points, it's going to be, first point is going to still be 0, 0. The next point is going to be negative 1/2. So I'm going to go to the left 1/2 and up 1. Then I'm going to go to the left 2 and up 2. Then I'm going to go to the left 4.5 and up 3. Let me just check if that's 1, 2, 3, 4.5, and I went up 3. Right, that looks correct. And then do the vertical translation. So move all these pink points down 1. And actually, I don't need to color them purple. I'm just going to move all these down 1 step. So if I do that, it gives me the following graph. All these have kind of a purple step down, right? So I'm just kind of making sure that we went down 1, down 1, down 1, down 1. Okay. So now let's go to example 6, and this is the one that I said was a little bit different. We have to create an equation, and so it's kind of like what we were doing in the mass reconnect. So cube root, it's the 3 with the square root symbol, right? Then we're going to horizontally expand by a factor of 3/4. So horizontal expansion or dilation means that we're going to put the 3/4 inside. So it's going to look, let me see if it'll fit in the frame. So it's going to look something like this. It's going to be cube root of negative, no, not negative, sorry, of 3/4 x. Like this. So I'm going kind of step by step. So we're going to have a cube root in there, a 3/4 inside, and then we're going to translate 11 units up. So it's plus 11. So my final answer is going to be f of x equals, so I'm going to write it in color combo. So it's going to be cube root of 3/4 x, and then plus 11 is going to be outside. So without color coding, right, so that's example 6. Let's look at example 7. In example 7, we have the square roots. We have reflection and horizontal compression, but we can kind of combine these. This is kind of a -2 situation, and then translating 9 units down, that's -9. So if I color code, it's going to be square root of -2 times x minus 9. So without color coding, it would be the square root of -2x minus 9. All right. Well, thank you for joining me today, guys, in these notes. I'll see you again in class, and in class, if you have any questions, you can make sure to bring them up, and we can go over them before I give you guys the assignment. Have a great day, guys.